Hey guys, so in this video we're going to be doing our review of the trigonometry unit. There were a few different things that I said you should know before the exam. So you should understand the basic trigonometric functions for starters. Alright, so what do I mean by that? I mean you should understand what sine theta, cosine theta, and tangent theta actually are, like in the context of a triangle. And we're going to talk about it in this video and maybe spill over into the next video. But you should know those basic functions. You should know the trigonometric identities. You should know the trig identity. So that was just those kind of useful formulas like sine squared theta plus cosine squared theta equals 1. For example, the other one was sine theta divided by cosine theta equals tangent theta. But you know, that kind of stuff, that's trig identities. The third thing you need to know, can I fit it over here? Yes, I can. The third thing you need to know is the trig table. So that's the thing that you had the quiz on by now. So that was sine, cosine, tangent, cosecant, secant, and cotangent for the angle measurements of 0, 30, 45, 60, and 90 degrees. You should know how to fill out that table. I'll make it easier on you. I'll either give you the whole thing and like fill out half of it, or I'll give you half of it and I'll fill out a couple here and there and let you fill out the rest of them, but something like that. Alright, that trig table is something that in principle can be finished in 60 seconds. So it's not something that's going to take a long time on your exam, but make sure you know how to do it. Okay? And the last thing that I asked you to know is sine law and cosine law. Okay, so right off the bat I want to tell you that for trig identities, it's really hard at this level for me to give you a question where you have to recognize for yourself, oh, I need to use a trig identity here to get the answer, or else I'll be stuck. You need to practice more with these kinds of things, and I think you'd be capable of it, but maybe an exam setting isn't the best place to test whether you're capable of it. So for the trig identities, if I want you to use one, I'll tell you. I'll either write hint, use your trig identities, or I'll say, for this question, I want you to use a trig identity to tell me this, okay? Something like that. And once again, remember you're allowed to bring a bring a calculator to your final exam. All right, so for your trig identities, I might give you like, oh, sine theta is, blah, 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 some number. Cosine theta is something else. What is tan theta? And you need to recognize using the identities. Maybe I'll tell you, use your trig identities to figure out the answer, and you have to figure out which identity to use. There were only two of them, this one and the other one, and you have to figure out, okay, how do I use those to figure out tan theta? All right, so trig identities, we're not really going to go over it because you just need to know what they are. We'll go over the basic functions and the trig table in this video, and then if we run out of time, then I'll make a second video for the trig review where we'll talk about sine law and cosine law. Okay, so let's start with the basic trigonometric functions. So on your paper, draw a right triangle. So a triangle that looks something like this. Okay, that was a little bit bigger than I would have wanted it, but something like that. Draw a triangle like this and put a little square in that corner so that you know it's a 90-degree angle, even if it doesn't look like one. And put like a little arc in this corner and write in theta. Okay? It matters which corner you write theta in because that will change the names of the sides of the triangle. Okay, so we had three different sides to the triangle. We had the opposite side, we had the adjacent side, and we had the hypotenuse. Now the hypotenuse is always the longest side of the triangle. And if you have a triangle like this, it might be easy to see which side is the longest side. If you can't really tell, it's always the one that's opposite this right angle. If you will, when you draw in that little square, the square is almost, this part of the square is basically pointing in the direction of the hypotenuse, if that helps. That this, you can think of it as like, a little arrow almost, that it's like, that it's pointing in the direction of the hypotenuse, like a little arrowhead or something. Okay? So that, I don't really like that though, so I'm gonna just make it a square. So your hypotenuse is the one that's opposite from the right angle. It's on the whole other end of the triangle. So your hypotenuse is this one, right here. And you'll notice, at least unless I'm going crazy, that I've always used the same orientation for the triangle. I've never drawn it a different way, really. And I've always put theta right here. So to keep things simple, I'll probably do the same thing on your exam, unless I'm forgetful. But otherwise, I'm going to try and make this easy for you. I'm not out to make you stress out about this test. I'm going to try and give you the easy examples for everything. I'm not going to make, your slopes crazy numbers. I'm not going to make your triangles look all funny. It'll be something just like what you've seen in the videos or in our classes. All right, so now we've got opposite and adjacent that we need to figure out. So the hypotenuse we've got already. The opposite side is the one that's opposite to this angle theta. So the one that's farthest away from the angle theta. You'll notice that there's two sides remaining, and one of them is touching the angle theta. The other one is all the way over there. So the one that's all the way over there is our opposite side. Okay, and then the last one down here must be, by process of elimination, the adjacent side. Okay, so we've got the hypotenuse, we've got the adjacent side, and we've got the opposite side. Now, there are a couple of ways you can remember the relationship between the trigonometric functions and these sides. We'll talk about both methods that you can use to remember them. But let's remind ourselves of the trigonometric functions. So we've got sine theta, which is equal to something. We've got cosine theta. I'll put cosine theta here. Cosine theta, which is equal to something. And then we've got tan theta, which I'll write over there, which is equal to something. Tan theta, which is equal to something. Okay? So sine theta is equal to what? We've got our little acronym, the first one. Can you still see that? Yes, okay. So we've got our acronym, the first one, the one I find less creative, but the one I still use nonetheless. SOHCAHTOA. I don't find this particularly creative because this is a nonsensical collection of letters unless you understand the math. So if you can memorize this, you might as well just memorize that. But nonetheless, this can be useful at times. So if we just use this, well, we've got S for sine, O for opposite, H for hypotenuse. We've got sine, O for opposite, H for hypotenuse. So the sine of this angle theta is going to be the length of the opposite side divided by the length of this hypotenuse here. Okay? Cosine, C for cosine, A for adjacent, H for hypotenuse. Cosine equals adjacent over hypotenuse. Okay? This is only for a right triangle. If you don't have this right angle, this stuff doesn't work. Okay? And then tangent, opposite, adjacent. So we've got tangent of theta is opposite over adjacent. Okay? So that's one way that you can remember it. The other way that you could alternatively remember this requires a renaming of two of the sides. And I like the name of this one better, but I never grew up calling the sides by the same thing. So for me, it's more difficult to make the switch. I look at the triangle and I naturally think opposite and adjacent, but my parents who grew up in India think something different. They think of base and perpendicular. Now the good thing with SOHCAHTOA is at least you can sort of pronounce it. If you tried to do the same thing here, you'd get this is not helpful. This is even less helpful than SOHCAHTOA, right? This doesn't aid you in figuring out whether sine is hypotenuse over base or perpendicular over hypotenuse. This doesn't really help because you need to memorize all these letters and you can't even pronounce all those letters, so you might as well just memorize that stuff. So instead, we just don't memorize the letters. We don't memorize the letters, we memorize a phrase instead. A phrase that makes a lot more sense than SOHCAHTOA, in my opinion. All right, so the phrase, in case you've forgotten, I just need space to write it. Maybe I'll just like sort of start here and then just keep going. So the phrase is, some people have curly brown hair through proper brushing. And I sort of had to erase the label of the hypotenuse. So I'll move over in case I hope you can see that, and I'll just rewrite hypotenuse in here. Hypotenuse. So, some people have curly brown hair through proper brushing. If you don't make those awkward pauses here and here as though there's commas there, then it's a logical sentence. Some people have curly brown hair through proper brushing. It makes sense. As a sentence, it's easy to remember. At least easier, I think, than SOHCAHTOA. But then the way it helps you remember this stuff is S for sine, C for cosine, T for tangent, P for perpendicular. So we've got a P there, and we've got a P there. B for base. We've got a B there, and we've got a B there. And H for hypotenuse. We've got two of those. So S for sine, P for perpendicular, and H for hypotenuse. So we've got S, P, H, some people have. And then cosine is very similar. Theta equals C, B, H, curly brown hair, curly brown hair. And then the last one, through proper brushing, tangent theta. So the reason you have to be careful here is because the base in this example makes a lot of sense. But if your angle theta was up here, then this side is the base and this side is the perpendicular, which sort of doesn't make as much sense. So that's the reason why I don't like it as much. Otherwise, I think this one is infinitely better than SOHCAHTOA. But that's just my my opinion. I think, yeah, well, we still got time. So that's it for the basic trigonometric functions and how they relate to the sides of a triangle. Now what we're going to do is we're going to do a quick run through of that trigonometry table. I won't go through all the details because you have the videos on that. So as long as you can get good enough Wi-Fi, you can rewatch those whenever and wherever you please. But so we've got this table. We've got this one. Maybe I'll make this bigger. So we've got a line there. We've got 1, 2, 3, 4, 5, 6, perfect. And then we go this way. Something like that. All right, so this is what you need to draw on your page. You want to have 7 rows and 6 columns. And in your rows, you're going to want to write sine theta, cosine theta, tangent theta, cosecant theta, secant theta, and cotangent theta. And then across the top, you're going to want to write 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. All right? Now the sine line, you can remember one of 2 ways. Either you can memorize it, or if you're having trouble memorizing it, remember that it just goes from square root of 0 divided by square root of 4 up to the square root of 4 divided by the square root of 4. In one of the other videos I talked about how you got root 0 over root 4, root 1 over root 4, and so on, all the way up to the end. But in the simplified form, also you can write this whole thing however you please. You can write it all in this form if you wish, but you don't have to. I'm going to write it, and if when I fill it out, I'm going to fill it out the way I've done it. So I would fill it out like 0, 1/2, 1 over the square root of 2, the square root of 3 divided by 2, and 1. So if I fill out any of those values for you, I'm going to write them this way, not that way. All right? Now, your sine line, you can memorize or learn it that way or whatever. The cosine line, you don't have to memorize anything. It's the same as the sine line, but in reverse. So instead of going in this direction, we just do the same order, but in that direction. We do the same sequence in that direction. So we got a 0 here. We got 1/2, 1 over the square root of 2, the square root of 3 divided by 2, and 1. There's your cosine line. Now your tangent line is the numerator from your sine value divided by the numerator from your cosine value. The reason it's the numerator is because if there's a fraction, the denominator is always the same, so they cancel out if you do all the math. But basically it's the numerator, so you've got the 1, and the root 3 divided by the denominator, the root 3, the 1, and the 1, for example. Okay? And if it's a whole number, then the number that you see is the numerator. So the 0 is the numerator for sine here, the 1 is the numerator for cosine, same thing over there. And if you have 0 as the denominator for tangent, so basically if your cosine numerator is 0, you get that weird looking thing at the end that doesn't make any mathematical sense. So 0 divided by 1, 0. 1 divided by the square root of 3, you just write that. You don't have to simplify it or anything. 1 divided by 1, that's just 1. The square root of 3 divided by 1, well, if it's divided by 1, I haven't changed it, so I can just write the square root of 3. 1 divided by 0. I can't divide by 0, so I write UND, undefined. All right, that's the tangent line. I know, once again, this video is getting a little bit long, so I'm going to sort of quickly go through the second half. The cosecant line is the same as the sine line, but flipped over. So all the fractions get flipped over. 1, nothing happens to it when you flip it over. But 0, when you flip it over, you get undefined. Okay, so if I flip over 1 over 2, it becomes 2 over 1. Anything over 1, I don't need to write the over 1 part, so I can just write 2. Square root of 2 over 1, so I just write the square root of 2. 2 over the square root of 3, I have to write both of those components. And then 1, nothing happens when you flip it over. So that's cosecant theta. For secant theta, you can, if you wish, flip over the cosine line, or you can just do the cosecant line in backwards order. So we start with undefined over there, and then we get 2 root 2, 2 over root 3, and 1. So that's just the cosecant line backwards. And then the last one, the cotangent line, you can either flip over the tangent line, or you can do the tangent line backwards. And you'll notice there's actually other ways that you can do it as well. You could do cosine numerator divided by sine numerator, for instance, and there's other ways you can do it as well. But basically the easiest way, I think, is to do the tangent line in reverse order or flipped over, whatever you prefer. So I prefer the reverse order, so I'll put the 0 over there, and then I go 1 over the square root of 3, 1, the square root of 3, and undefined. So basically it's just the tangent line but backwards. So I start at that end and I go this way. And that's the whole trig table. If I give you this whole thing, I haven't quite decided yet because I haven't written up your exams yet, but this whole thing, if I give you the whole thing, I'll fill out half of it, or something like that. You've got 30 things to fill in, so I would fill in 15 of them or so. And if I only give you the top half, if I get rid of this whole bottom chunk here, then I'll only fill in like 3 or 4, so you still have to fill out 10 or more. So try and memorize this. I'll try and make it easier for you. If I give you all 30, then I'll fill in a lot of these bottom ones because you don't really work with these bottom ones, and you should know these first 3 rows. They just come in handy a lot. Alright, so that's it for the first half of our trigonometry review. I know this video once again has gotten a little bit long, so in the next video we will pick up by doing sine law and the cosine law. Alright, I will see you there.